Hi students, this is Mr. Yao. Today we are going to talk about 1.4, where we will learn how to factor four-term polynomials by a method called grouping. But before we do that, let's actually go over a problem that we have learned previously. Let's multiply these. You can either use the line method or you can use the box method. I'm actually going to use the line to connect them, so it's just easier for me to get to the next step. So first thing, you're going to multiply the x squared with the x and the 3 in the second parentheses. You get x cubed and then plus 3x squared. And then you're going to multiply the negative 4 with the x and with the 3. So you're going to get a minus 4x and a minus 12. And now you check if you can combine any like terms. Third power, second power, first power, and no power, well, which means you can't exactly combine like terms. Okay, now we're going to go the same route as the previous lesson. Let's say I'm not giving you this, I'm crossing that out. The question is, how can we get from this step to the previous step? You can pause here and kind of think, you can come back and check here. If you haven't noticed, I purposely used two different colors and to kind of guide you to what's happening. This is four terms, and this is also called factoring. And so far, we have only learned to factor out the GCF. So that might be something we actually want to try. So first, let's look at these four terms. X cubed, x squared, x 12. You can't exactly factor out anything for all four terms, but let's focus on the first two terms and the last two terms. So I asked you to factor out these two. You may have noticed, well, they don't have any number that they share, but I can take out an x squared. And then if I look at the last two terms, which is again negative 4x and negative 12, we have emphasized if you start with a negative sign, you have to also factor out a negative. So if I factor out, they actually would factor out a negative 4. Now what do you notice? X squared and minus 4 is actually in the first parentheses. As for the second parenthesis, well, of course, that will be what's left. So this is kind of the basic idea of today's lesson. Now let's actually get into the lesson. Factor by grouping is typically used when there are four terms in the polynomial. And later in this unit, we will learn to factor when we have three terms. You can also separate those three terms into four terms, so you can use this factor by grouping method. Let's have a look at an example with steps. First step, you are going to have to look for a GCF. This is a very important step. You'll always do this no matter what kind of factoring question you have. You'll always look for the GCF first. In this case, we do have a GCF. Even though they don't all have a variable x, because the last term doesn't have any variable attached to it, but look at the coefficients. We have a 2, a 6, a negative 8, and a negative 24. They're all even numbers, so the GCF in this case is a 2. So I am going to factor out the GCF. 2. Then we have x cubed plus 3x squared minus 4x and minus 12. Now, if you haven't noticed, that's exactly the previous question I just gave you. So let's kind of use that idea. Step 2, group the first two terms together and the last two terms together. For now, we are going to leave this 2 in the front, but don't forget, at the very end, we do need to include that back into our final answer. But for now, we are going to write the first two terms, group them together, x cubed and 3x squared. And then the next two terms, we're also going to group them together. Next two terms, we have a negative 4x. Oh, let me actually use a different color. We actually have a negative 4x and a negative 12. As for the middle, well, for now, I'm just going to keep as a plus sign because there's no sign to connect them. I have included that negative sign with a 4. Okay, next step. We are going to factor out the GCF of the first two terms and then factor out the GCF of the last two terms. For x cubed and 3x squared, we have learned in the previous lesson, we just pick the most amount of x that we can take out. Out of the 3 and the 2, we can take out 2 of them. So when we factor, we're going to factor out an x squared. Then let's see what's left. You're going to divide everything by x squared if you're still kind of getting used to that factoring GCF process. Cube, take away 2 of them, you have an x left. 3x squared, take away x squared, you have a 3 left. Let's also do it to the back. Negative 4x and negative 12, they do not share any x. They all both, well, the front is a negative sign, so you do need to factor out a negative sign. Between the 4 and the 12, you can factor out a 4. Next, if you factor out a negative 4, again, that means you're dividing each term by negative 4. You're going to have an x left for the back. Negative 12 divided by negative 4, you're going to have a positive 3 left. Okay, now let me direct your attention to these terms. X plus 3 and x plus 3. Voila, they are the same, which means now if I look at the whole thing together, that would be a common factor that both parts share. So look to see if there's more GCF. Because they have the same x plus 3, I'm going to leave that. Okay, then let's see what we have left if we actually have that x plus 3 right there. In the front, if we take away the x plus 3, we have x squared left. That x squared is going to come down. In the back, if we take away that x plus 3, we have this negative 4 left. So minus 4. In that case, the final answer should be the product of two binomials. So there we go. And because factoring is the inverse operation for multiplication, you can always choose to multiply through to see if you will get the original answer back. Right now, if you do that, you will notice you'll get something slightly different. You will only get this x cubed plus 3x squared minus 4x minus 12. That's because we have factored out a 2 in the first step. So don't forget to include that in your final answer. So the final answer is 2 times x squared minus 4 times x plus 3. There we go. That is factor by grouping. So how can you check your answer? I just kind of talked about that. You can multiply the two binomials together to make sure you did it right. Now let's go through a few more examples to kind of get used to that process. For terms, you're going to group the first two together and the last two together. But before that, don't forget the first step is always to check for the GCF. In this case, 10, 5, 4, 2, no GCF, x squared, x, another x, and a 2. Well, no GCF. So in this case, we are just going to start factoring out start grouping them in pairs. You can technically just do it that way. Or you can choose to write it out. 10x squared plus 5 plus 4x plus 2. Again, we typically just keep the middle as a plus sign. We'll just always attach the sign to the term. Next, we are going to factor out each part. Oh, I forgot an x right there. Okay, we're going to factor the first part. 10 and 5, I can factor out a 5. And x squared and x, I can factor out an x. After I do that, in other words, I'm dividing both terms by 5x. I will have a 2x and a 1 left. That's the first part. Second part, between the 4x and the 2, I can factor out a 2, which again is a positive 2. And then divide each by 2. 4x divided by 2 is a 2x. 2 divided by 2 is a 1. Now you may have noticed for both parts, the first part I have this 2x plus 1. For the second part, I also have this 2x plus 1. That is what they share. So 2x plus 1. If I take away 2x plus 1 from both parts, in the first part, I will have a 5x left. In the second part, I will have a plus 2 left. So now I can put them together. And that is my final answer. Now you can try example 2. Let's go through the same process. First step, always check for GCF. There's no GCF in this case because not all the terms have x, not all the terms have y, and the numbers, they do not exactly share anything. So I can start grouping them together. xy minus 2y. And again, I typically just keep the middle as a plus sign and attach that sign with the x so that I can remember when I factor, I need to factor out that negative sign. There's going to be negative x plus 2. This also helps to make sure that when I factor, I'm taking that negative sign from both of the terms on the end. Okay, let's continue. For the first part, xy and negative 2y, they share a y, which means I'm dividing both parts by y. I will have an x left in the front, and then a negative 2 left on the back. As for the back, negative sign to begin with, so I do need to factor out a negative. But remember, in this case, because we need a number, you are actually factoring out a -1. And then we have an x left from that, because you're dividing everything by -1. 2 divided by -1 is a -2. And if you check, the two parentheses are the same again. So I can just put them on the back. And let's see what's left. If you take away the x minus 2, you have a y left in the front. And then you have a -1 left on the end. Okay, this is why I emphasize when you factor out in this case, you do need to write that -1. If you didn't, and you are trying to see what's left, you might be like, oh, I don't have any number here, so let me just leave a y, which is not going to be right. You do actually need to have the 1 there, almost like a placeholder, so that you actually do have, when you multiply back, you will get the original question back. Now let's move on to example 3. Same process. Let's look for the GCF first. X cubed, x squared, x, no x. So no variable that's being shared. 7 and 5. Well, they already don't share any numbers, so I don't have a GCF in this case. Let's group them together. 7x cubed minus 5x squared minus, plus. Again, I'm attaching the negative sign with the term, so it's -42x inside the parentheses plus 30. This also makes sure I'm not just messing up the signs, because I can take care of that in the next step. The front, 7x cubed and -5x squared, they share an x square. They do not share any numbers. So if I take away the x squared from both, I will have a 7x left in the front and a -5 left on the back. Next, -42x and 30. They do not share any x, but -42 and 30, well, first they will share a negative sign. They can both be divided by 2 to begin with, or if you notice, they can both be divided by 6. Okay, after I take away a -6 from both parts, -42 divided by -6 is a +7 with an x. The 30 divided by -6 is a -5. Again, inside the parentheses, they are the same, so I can leave that on the back. As for the front, I can just write down what I still have left without the 7x minus 5. I still have an x squared, and I still have a -6. There we go. That's example 3. Example 4. First, let's check the GCF. GCF. In this case, you may notice every single term at least has an x. Not all the terms have a y, so y is not part of the GCF. And then 12, 6, 8, 4, they're all even numbers. So you can at least take away a 2. So let's try that. 2x, let's take it out, which means dividing every single term by 2x. So I'm going to have 6xy minus 3y minus 4x minus 2. That's what I have left. And now you can check again. Check the numbers. You have a 6, 3, 4, and a 2. Well, that means there's nothing you can take out. So we did get the GCF correctly, which is 2x. And then I'm going to leave that 2x for now, and I'm going to take care of the rest. I'm going to take care of the 4 terms left to do my factor by grouping. So I have 6xy minus 3y, and then just do a plot sign in the middle and attach the negative sign to the terms. You have a -4x and a -2. Let's start taking things apart. In the front, 6xy and -3y, they share 3y. And then I have 2x plus, not plus, minus 1 left. Again, divided each one by 3y, you will be able to find out is 2x minus 1 left. Okay, for the back. So -4 and a -2, they share a -2. So I'm going to divide each part by -2. -4x divided by -2, that's a +2x. -2 divided by -2, that's a +1. Well, for previous questions, the two parentheses were the same. That's why we can keep factoring. However, for this problem, if you check, oh wait, the two parentheses are not the same, which means they actually don't share anything in this front part and the back part. So you can't exactly do any further factoring. In this case, that means this problem from here is not factorable anymore. So you have to go back to the first step and see what you have done. In this case, the final answer would still just be 2x times 6xy minus 3y minus 4x minus 2, because the only thing you can do is take out a GCF, because these two terms, they are not the same. So you can't keep going to the next step. Only when they're actually the same, then you can actually keep factoring. That's why you have to pay very careful attention to the negative signs. Because in this case, when both are divided by a negative, you actually change that sign to a plus. That is not wrong if you follow the procedure and do them correctly. Just in this case, you can't keep factoring. So be very careful with that. It's example 4. Now let's go to the last example. Same process, identify the GCF first. In this case, not every single term have an A, not every single term has a B, and as for the numbers 3, 1, -3, -1, they do not share any numbers. So we can continue to start by our grouping. 3a squared plus ab squared, that's plus sign in the middle. We'll do -3ab and minus b cubed. Let's start putting everything. Start factoring out some GCFs for each part. First, 3a squared and ab squared at least share an a by each part by a. Then you have a 3a left in the front, and you have a b plus left on the back. Next, I'm going to factor out the backside. -3ab and -b cubed. At least they share a negative sign. They do not both have a number. They do not both have a, but at least they have a b. And when I take away a -b from both parts, the first, you have a 3a left. The back, -b cubed divided by -b, you do have a positive b squared left. Great. In this case, the two parentheses are actually the same. So I can actually keep that on the back and see without that what I still have for each part. In the front, I have an a left. On the back half, I have a minus b left. Now, if you actually want to be more precise to put this into standard form, well, then you can't put the b squared in the front because that has a higher degree compared to the 3a. But no matter what, this is your final answer for example 5, and that is everything for 1.4 lesson. Thank you.